So chapter 17 is all about redox reactions. Now we talked about redox reactions all the way back in chapter 4. Remember, redox is short for oxidation reduction reactions. Both things have to occur. So in redox reactions, I have a transfer of electrons. Somebody's going to lose electrons, somebody is going to gain electrons. The reducing agent is the one that is losing the electrons. The electrons are going into the oxidizing agent. Now this is kind of backwards. Remember, we said oxidation is the loss of electrons. Reduction is the gain of electrons. There were two different ways that we talked about remembering this. One was oil rig, that's a G. Oxidation is loss of electrons. Reduction is gain of electrons. The other way that we could remember it was Leo the lion goes grr. Loss of electrons is oxidation. Gain of electrons is reduction. Okay? Now, if I am being oxidized, I am losing electrons. I'm called the reducing agent because I am reducing something else. If I'm being reduced, I'm gaining electrons. I'm called the oxidizing agent because I'm causing something else to be oxidized. Okay? So those two are opposite each other. Okay? Now, an oxidation number is how we're going to track this. It's going to be a positive or a negative number. And what it's really doing is it's keeping track of the electrons. So I'm using the oxidation number to tell whether something is gaining electrons or losing electrons. It's really important to remember that even though we show an oxidation number up above elements, it's not the same thing as charge. It can be the same thing, but it's not always the same thing. Okay? So we've got some rules for oxidation numbers. Now I said it can be the same as charge. If I have an ion, monoatomic ion, so for example NaCl, Na's oxidation number would be +1, Cl's oxidation number would be -1. So in ionic compounds, monoatomic ions, the charge is the same. If I have an element, okay, so just regular sodium, not NaCl, it's going to be 0. Now, there are a bunch of other rules, but basically, one of the things that we usually want to start with is our elements. Elements are always 0. Our ionic compounds, our ions are always their charge. And then I can usually look for oxygen. Now, oxygen, whether it's an ionic compound or not, is usually a -2. The only exception is when it's that peroxide ion. Okay? So here's the way oxidation numbers work. Sodium, as a regular element, has an oxidation number of 0. Potassium, as a +1 monoatomic ion, has an oxidation number of +1. Oxygen, as an element, by itself, even though it's combined with other oxygens, it's not combined with any other element, is still 0. Now, where it starts getting weird is if we have things where it's not necessarily regular ions. So here I've got NO3 -1. Okay? Now, this whole thing, when I'm done, has to have a charge of -1. My oxygen, I said, was -2. I've got 3 of them. So oxygen is contributing -6. The whole thing has to be a -1, So N has to have an oxidation number of plus 5. Positive 5 minus 6 equals negative 1, which is what the whole thing has. Okay? Down here, I've got an ionic compound. Mg is still going to be its ionic charge, so that's a plus 2. Oxygen is going to be its ionic charge. It's a negative 2. To determine phosphorus, oxygen is a negative 2 times 4. So it's contributing 8 negatives. Okay? I know that this whole ion, phosphate, has a negative 3 charge. That means phosphorus has to be a plus 5. If I've got 5 positives, 8 negatives, I'm left over with 3 negatives, which is what phosphate ion has. Take a second, figure out the oxidation numbers for H2SO4. Now, half reactions are usually used as a method of balancing chemical reactions. And half reactions are actually what we're going to use for some reactions that we couldn't necessarily balance otherwise. Okay? So when we're looking at half reactions, what we're looking at is the reduction and the oxidation. The reduction half reaction is showing the element that is being reduced. Reduction is gain of electrons. So my electrons are going to be reactants. Oxidation is loss of electrons. Since the electrons are going away, they are going to be products. I always have both things happening together. Somebody's being oxidized, somebody's being reduced. So when I look at half reactions, Na is turning into Na+. It's going from an oxidation number of 0 to an oxidation number of plus 1. In order to become positive 1, it needs to lose 1 electron. Okay? Copper is going from a plus 2 to an element of 0. In order to go from a positive to neutral, it needs to gain 2 electrons. So when I set up my half reactions, I'm going to do 1 for oxidation, 1 for reduction. So Na is going to Na plus 1. We said it has to lose electrons, so it's losing 1 electron. This is my oxidation half reaction. Cu is going from 2 plus to just Cu. We said in order to do that, it has to gain 2 electrons. So my electrons are reactants. Now, because it's gaining electrons, it's being reduced. The Na is being oxidized. The Na is the reducing agent because it causes copper 2 plus to be reduced. Copper 2 plus is reduced, so it is the oxidizing agent because it makes Na be oxidized. Now, right now I've got my 2 half reactions. If somebody's gaining electrons, somebody else has to lose. But my electrons also must be balanced. So in order to make this balance, right now I've got 1, I need 2. I'd have to multiply this whole thing by 2. So my balanced reaction, I have 2Na plus Cu2 plus. Now, I've got 2 electrons as products because I multiply both sides, 2 electrons as reactants. I ignore my electrons because they're going to cancel out. It's going to make 2 times Na plus 1, and it's also going to make Cu solid. This would be my balanced oxidation reduction reaction. Okay? So it's really important to remember, oxidation is loss, reduction is gain of electrons. Whoever is being oxidized is the reducing agent. Whoever is being reduced is the oxidizing agent. My 2 half reactions, the electrons must equal each other.